Welcome to the Quick Start tutorial series for Visual Cam 2015 for Geomagic Design, brought to you by Mexsoft. Today we'll be demonstrating the mill module. Let's begin by opening the part model in Geomagic Design. From the Geomagic Home dialog, select File and then Open. Locate the Visual Cam 2015 for Geomagic Quick Start folder shown here. Then select the Geomagic part file named Mill Quick Start Tutorial and then pick Open. To launch the Visual Cam Mill module, select the Add-ons tab from the ribbon bar. You will observe an entry called Visual Cam 2015 on the ribbon bar. Selecting this button will display a drop-down menu from which one of the three machining modules can be chosen. Select the mill entry and this will create the Visual Cam 2015 dialog bar as a separate tab next to the Design Explorer tab. You will see two dialogs on the left side of your screen. The one on the top is called the Machining Browser, and below it the Machining Objects Browser, displayed in the CAM browser window of the Design Explorer. You can resize the height and width of each browser, making sure that all of the command icons and menus are easily accessible. We will perform the following basic steps in machining this model. First, we'll define the machine and the post-processor to use. Then, we'll define the setup, including stock geometry, material, and work 0. Then, we'll create and select a tool to use for machining. We'll create the machining operations, including the feeds and speeds, the clearance planes, and other cutting parameters. Then we'll generate the toolpaths, simulate the toolpaths, post-process the toolpaths, and generate shop documentation. Let's start by defining the machine and the machine tool coordinate system to use for this job. From the Program tab, select Machine to display the dialog. Under the Machine Tool Coordinate System tab, select the World Coordinate System button. By default, the MCS, or Machine Coordinate System, is already aligned with the WCS, or World Coordinate System, so this step is not required for this part. Now select the Machine Tool Definition tab. Under Machine Type, set Number of Axes to 3 axes. Pick OK, and notice that the machine type now appears under the machining job in the Machining Browser. Next, we'll define the post processor. From the Program tab, select Post to display the dialog. For the current post processor, select HOS from the list of available posts. Then set the Posted File extension to NC. Other file extensions are available depending on your machine requirements. Pick OK and notice that the post type now appears under the machining job in the Machining Browser. Now, let's define the machining setup. If there is no setup one listed under your machining job, the system automatically creates one when a work 0 or an operation is generated. However, by default, the MCS, or Machine Coordinate System, is already aligned with the WCS, World Coordinate System, so this step is not required for this part. However, in production, you can have multiple setups and assign different machining orientations for each. In this step, we'll define the raw stock from which to cut the part. From the Program tab, select Stock, and then select Box Stock from the menu to display the dialog. Under Dimensions, set the length L to 10.0, width W to 6.0, and height H to 0.125. Note that the stock dimensions you enter here are measured from the corner of the bounding box selected in this dialog. Pick OK and notice that the stock type now appears under the machining job in the Machining Browser. If the stock does not display on the screen, select the Stock Visibility icon located at the base of the Machining Browser. Once the stock model is created, you can move it in alignment with the part if needed. From the Program tab, select Align to display the dialog. For Z alignment, select Top, and for XY alignment, select Center, and then pick OK. The stock is now aligned to the center of the part in the XY and the top of the part in Z. Next, we'll set the material for the stock geometry. From the Program tab, select Material to display the dialog. For material, select Wood from the list of available materials and then pick OK. The material texture is displayed in the stock simulation window. Select the Simulate tab and then pick Window to open the stock simulation window. If the material texture does not display on the stock, select the Material Texture Visibility icon located at the base of the machining browser. Now select the window icon again to close the stock simulation window. Now that the stock is aligned to the part geometry, in this step we will establish the work coordinate origin. This location defines the 0 point from which all toolpath points are interpreted by the controller. From the Program tab, select Work 0 to display the dialog. Then select Set to Stock Box. Then set 0 Face to Highest Z and 0 Position to Southwest Corner. This sets the machine home to the top of the stock material and the southwest corner of the stock geometry. Pick Generate and notice that the MCS is translated and that the Work 0 now appears under Setup 1 in the machining browser. To machine the part, we will now create a 1/2 inch flat end mill. From the Tools tab in the Machining Objects browser, select Create Edit Tools to display the dialog. Select the Flat Mill tool icon. Then set tool name as Flat Mill -0.5 in the tool diameter to 0.5. Under the Properties tab, set Material to HSS and set the tool number to 1. Now switch to the Feeds and Speeds tab and pick Load from File to display the dialog. From here, set Stock Material to Wood and Tool Material to HSS. Pick OK, and the computed cut feed rate and spindle speeds are transferred to the Speeds and Feeds tab of the Tool dialog. Now pick Save as New Tool. The tool is created and listed under Tools in Session on the left. Pick OK to close the dialog. Notice that the new tool is also listed under the Tools tab of the Machining Objects browser. Now we're ready to create our first profiling operation. From the Program tab, select 2-axis and then Profiling from the menu of 2-axis operations. This will display the 2 1/2 axis profiling operation dialog. Under the Control Geometry tab, pick Select Drive Containment Regions. The dialog is minimized and you are prompted to select a sketch or face edge for machining. We will now select the surface edges of the 3 inside hole features. While pressing the Shift key, select the first hole by clicking near its upper surface edge. Now, while the Shift key is still pressed, select the similar edges of the 2 remaining holes and then select the checkmark icon to complete the selection. The 2 1/2 axis profiling dialog comes back up, displaying the selected drive regions. They are also highlighted on the part. Notice that selecting a drive region from the list highlights the corresponding surface edge curve on the part. Now we switch to the Tool tab of the dialog. Select Flat Mill 0.5 under Tools. The 0.5 inch flat end mill is now selected as the active tool. Note that the tool parameters of the currently active tool are always displayed in the status bar at the bottom of the Machining Objects browser. Now switch to the Feeds and Speeds tab. Select the Load from Tool button. Visual Cam will retrieve the feeds and speeds parameters that were set when the tool was defined and associate them with the current operation. Next, we'll switch to the Clearance Plane tab. Set the clearance plane definition to Automatic and the Cut Transfer method to Clearance Plane. In the automatic mode, Visual Cam will determine a safe Z height for locating the clearance plane. Setting the Cut Transfer method to Clearance Plane will force all transfer moves to be performed in this determined clearance plane. When this dialog is active, the clearance plane is shown on the graphic screen. Now we switch to the Cut Parameters tab to control the cutting. Set the stock to 0. This means that we will not be leaving any thickness on the part after machining. Under the Cut Start Side section, check the box next to Use Outside Inside for closed curves, and then select Inside. Alternatively, you could use the Determine Using 3D Model option. In this case, VisualCAM would use the 3D model to determine which side of the curve to place the cutter for the machining. Now, select the Cut Levels tab and set Location of Cut Geometry to At Top. Enter 0.125 for the total cut depth. The cut depth is always set as an absolute value. This automatically sets the rough depth and rough depth per cut to 0.125. Next, we select the Entry-Exit tab. Entry-Exit parameters control how the cutter will engage material as it begins cutting and how it leaves the material as it completes cutting. Set entry and exit motions to none. Now pick Generate. The 2 1/2 axis profile toolpath is generated and the operation is listed under Setup 1 in the machining browser. The toolpath is also displayed in the graphics screen. Note that the display of the toolpath in the graphics screen can be turned on and off by selecting the toolpath visibility icon located at the base of the machining browser. The new toolpath can now be simulated to display the in-process stock model. Switch to the Simulate tab at the top of the machining browser. Pick Window to open the stock simulation window. Under Preferences, uncheck Simulate by Moves and adjust the slider to set the simulation speed, and then select Play from the Simulation tab. Additional simulation controls are available on the menu, such as stop, pause, etc. To view the cut model with textures applied, select the Material Texture Visibility icon located at the base of the machining browser. Now, we will turn our attention to machining the outer profile of the part. Again, we will create a simple profile toolpath, this time around the outer periphery of the part. First, close the stock simulation window from the Simulate tab. Switch to the Program tab in the machining browser. Select the 2 1/2 axis profiling operation we just created. Right-click on the selected operation and select Copy. Now, right-click again and select Paste. This creates a copy of the operation and places it below the original in the machining browser. Now, right-click on the second operation and pick Edit to adjust its parameters. Pick Remove All under the Control Geometry tab. Now pick Select Drive Containment Regions. While holding the Shift key down, select each of the edges that form the outer profile of the top surface, and then pick the checkmark icon to end the selection. Now switch to the Cut Parameters tab and change the Cut Start Side to Outside. We'll accept all of the remaining parameters and then pick Generate. The new 2 1/2 axis profile toolpath is generated and displayed on the graphic screen. Now, we'll select the 2 1/2 axis profiling operation we just created, select the Simulate tab, launch the stock simulation window, and then pick Play. Now, with the toolpaths complete, we're ready to post-process to an output text file containing G-codes that can then be sent to the machine tool to actually machine the part. First, close the stock simulation window from the Simulate tab. Select Setup 1 from the machining browser and right-click and select Post. This will post all operations created under the setup. By default, the part file name and the setup name are appended for the G-code file name. Also by default, the posted G-code file is saved to the folder where the part file is located. Now pick Post and the G-code file is displayed in Notepad where it can be viewed or edited manually. Now close Notepad. At any time, you can create an informational report of your machining operations. Switch to the Program tab in the machining browser. Select Setup 1, right-click and select Information to display and print the report. This dialog provides an estimate of the machining time required for the operations in the setup. You can perform the same right-click sequence on the machining job to determine the estimated machining time for all setups. Now pick OK to close the information dialog. You can also create a setup sheet by generating a shop document. This is typically used to instruct machine operators on how to set up and machine the part on the CNC machine. Select Setup 1. Right-click and select Shop Documentation. Select Template 1 and then click Save. This creates an HTML-based shop document that can be viewed in a web browser. You can perform the same right-click sequence on the machining job to generate shop documentation for all setups. This completes the Quick Start tutorial of the VisualCAM 2015 for Geomagic Design Mill module. For further assistance, you can visit the online help supplied with the program or visit www.mexoft.com for additional tutorials. Thank you.